Alright guys, so I'm going back to my old method of doing this just because I think it'll be a little bit faster for me to do it by hand than try and do it on the computer. Alright, so we've got 2y plus 1 to the third minus 24x equals negative 3. We want to show that the derivative equals 4 over 2y plus 1 squared. Alright, so I'm going to take the derivative of this equation. So, take the derivative. Well, we're going to take the 3, bump it down, keep the inside the same because we've got a chain rule here. Subtract 1 from the exponent times the derivative of the inside is 2, but because it had a y, we tack on dy dx. And then minus derivative of 24x is 24 equals the derivative of negative 3, which is 0. All right, so I'm going to do a little bit of tidying up. 3 times 2 is 6. 2y plus 1 squared dy dx. And I'm going to add that 24 over equals 24. We're going to divide both sides by 6. So now I get 2y plus 1 squared dy dx equals 4, and then we're going to divide by 2y plus 1 squared. So we get dy dx equals 4 over 2y plus 1 squared. All right, now the next one is write an equation for the line tangent. So we need two things for an equation of a line tangent, point and slope. So point, given. Slope, when I think slope, I think derivative. So we've got our derivative right here. So I'm going to plug in that point to find my slope. So m is going to equal 4 over, and then 2 times my y, which is negative 2, plus 1 squared. And we don't even need to use the x value because there's no x value in that derivative. So my m is going to equal 2 times the negative 2, that's negative 4, plus 1 is negative 3. Negative 3 squared is positive 9. So my slope is 4/9. So my equation of the line tangent is going to be y plus 2 equals m, which is 4 over 9 times x plus 1. Point slope form. That is my equation of the line tangent. All right, next one. Evaluate d2y dx2. That's the second derivative. That's what that's indicating to me. So I already have the first derivative. Now I'm going to just have to take that second derivative. So I'm going to just rewrite this as the first derivative equals 4 times 2y plus 1 to the negative 2. Okay, so that's how we would normally just rewrite to facilitate taking the derivative. So once again, it's a constant out in front, the coefficient, so we just need to do straight up chain rule. So take the negative 2, bump it down. Keep the inside the same. Subtract 1 from that exponent, then we multiply it by the derivative of the inside, which is 2, but because it has a y, dy dx. Okay, so now that's what my second derivative is, d2y dx2. All right, but I'm going to tidy this up. So I'm going to do negative 8 times 2. I'm going to bring that up here. So negative 8 times 2 is negative 16. And then we've got 2y plus 1 to the negative third dy dx. All right, now we want to find it at this point, negative 1 comma negative 2. I could either substitute in what this dy dx is equal to, either here or using my rewrite and plug that back in, or I already found what dy dx is at this point. It's 4/9. So this is 4/9 times -16 times 2 times -2 plus 1 to the -3rd. All right, so that's -3 to the -3rd. So that is going to be -16 times 1 over 3 to the third, -3 to the third, so that's -27 times 4/9. Could I simplify that? Yeah. Do I want to? Nope. Leaving it like that. All right, because we can do that. That's a numeric answer. All right, now we've got a derivative of an inverse, a derivative of an inverse. So to simplify that, the derivative of the inverse is going to be equal to 1 over f prime of my x value. So this is my switch x and y. So f prime of 1/6. So I want to find what the derivative is at 1/6 and then do the reciprocal of that. All right, so here's the derivative. I'm going to plug in 1/6 comma 0. So that's going to be 4 over, there's no x value, so 2 times 0 plus 1 is 2. So that's going to be 1 over 4. Final answer. All right.